Standard cell potentials, E-cell calculations. I'm Mr. B. The cell potential, or E-cell, is the measure of the potential difference or voltage between two half cells in an electrochemical cell. The potential difference is caused by the ability of electrons to flow from one half cell to the other. A redox reaction occurs when a certain substance is oxidized while another is reduced. During oxidation, this substance loses one or more electrons and thus becomes positively charged. Conversely, during reduction, this substance gains electrons and becomes negatively charged. The cell potential, or E-cell, is measured in voltage, which allows us to give a certain value to the cell potential. Suppose we're asked to calculate the standard cell potential of a copper-silver voltaic cell. The cell notation indicates what's happening in each half cell, where Cu/Cu plus 2 indicates that the copper metal is being oxidized into copper 2 plus cations at the anode, and Ag+/Ag indicates that silver cation is being reduced into silver metal at the cathode. The diagonal lines represent the phase border between the solid and aqueous phases. The double vertical lines represent the salt bridge. The actual voltage is displayed on the voltmeter. In order to determine the standard cell potential, we must begin by using a standard reduction of potentials table. The data values of the standard electrode potentials are given in the table in volts. This is all relative to the standard hydrogen electrode, which has a voltage of 0.00. This table contains values for the amount of energy given off or absorbed when a substance undergoes reduction in voltage. A plus sign means that the process is favored, and a minus sign means that the process is not favored. These processes are not favored or will not occur because the values have a negative sign. The closer a substance is to the top of the table, the more likely it is for that substance to undergo reduction. Let's begin with the reduction and oxidation potentials for copper 2 plus cation. Fully reduced copper 2 plus cation will form copper metal with a reduction potential of plus 0.34 volts. The oxidation potential has the opposite sign compared to the reduction potential, where the oxidation potential of copper metal forming copper 2 plus cation releasing 2 electrons is negative 0.34 volts. The fully reduced silver cation will form silver metal with a reduction potential of positive 0.80 volts. The oxidation potential has the opposite sign compared to the reduction potential, where silver metal forming silver cation while releasing 1 electron is negative 0.80 volts. Now for a practice problem. Calculate the standard cell potential, or E-cell, for a silver-copper galvanic or voltaic cell given the following net ionic equation, where 2 moles of aqueous silver cation reacts with 1 mole of solid copper, producing 1 mole of aqueous copper 2 plus cation and 2 moles of solid silver. Silver cation is higher on the reduction potentials table, so its reduction is favored over the reduction of copper 2 plus cation. So in the half reaction, we write E minus plus Ag plus aqueous, produces Ag solid with a reduction potential of plus 0.80 volts. Copper 2 plus cation is lower on the table, so it will undergo oxidation. So we must reverse the sign from a plus 0.34 volts to a negative 0.34 volts. So the half reaction becomes solid copper produces aqueous copper 2 plus cation while releasing 2 electrons, and the oxidation potential for this process will be negative 0.34 volts. Remember, do not multiply the voltage by the coefficients in the balanced net ionic equation. Given this information, we may now calculate the standard cell potential for a silver-copper or galvanic or voltaic cell. Copper undergoes oxidation. Its oxidation potential is negative 0.34 volts. Silver undergoes reduction. Its reduction potential is 0.80 volts. The formula to use is standard cell potential is equal to the standard reduction potential plus the standard oxidation potential. The value for the standard reduction potential is plus 0.80 volts. The value for the standard oxidation potential is negative 0.34 volts. After adding the two values together, we get the following answer, where the standard cell potential is positive 0.46 volts. And since this value is positive, the reaction is exothermic and will occur. A second method would be to subtract the voltage of the substance that is lower on the table from the voltage of the substance that is higher on the table. So we use the data directly from the table and subtract the values, where standard cell potential is equal to the standard reduction potential of A minus the standard reduction potential of B. So in this case, the standard cell potential is equal to plus 0.80 volts minus a plus 0.34 volts. This will also equal plus 0.46 volts. If the voltage was negative, the reaction would not occur, and it would be non-spontaneous. This concludes my lesson on standard cell potentials, E-cell calculations. I'm Mr. B.